Number 1, you're solving for x, and then you're going to identify what each of the angles is going to be equal to. So when solving for x, you first have to set it up as an equation to solve for a triangle. All triangles are equal how many degrees, guys? 180. So I'm going to set this up. It doesn't matter which angle I start with, but it just means that I'm going to add all three angles together, and it's going to equal 180. I'm going to go ahead and identify this angle in blue, so I'll just say, hey, this is 5x minus 3. I'm going to identify this one in green. That's going to be, so hold on, this, so plus, we'll have 2x plus 7. And then I'm going to have this one be my pink. Let's say x plus 4. And all of this is going to be set equal to 180. Okay? So there's my equation. There's my three angles. Separating them by color so that way you guys can see that they are three different angles. And then I'm going to go ahead and solve by first combining my like terms. So by like terms, I mean terms that have the exact same variable or terms that are just constants. Okay, so here we've got the 5x. We've got a positive 2x. I'm including the operation in front of it. And a positive x. Now this doesn't have a coefficient written there, but we know there's an invisible what? 1. There's an invisible 1. So we're going to go ahead and put that 1 in front of it. Okay, I can rewrite this as 5x plus 2x plus 1x, and that's going to equal 8x. Okay, then I also have my constants. I have a negative 3, a positive 7, and a positive 4. Okay, when I combine these together, negative 3 plus 7 plus 4, it's going to give me a positive 8. So I have 8x plus 8, and that's all still equal to 180. And then I can go ahead and solve. I would subtract 8 from both sides. That'll give me 8x is now equal to 172. And then I'm going to divide both sides by 8. And I'm going to get that x is equal to 21.5. It's okay to have a decimal. So I solved for x. That part is done. I finished that. Now I've got to identify each angle. I've got to work out each angle. So I'm going to go ahead and come on over to this side. And I've got 5x minus 3, which is going to be the same thing as 5 times my 21.5 minus 3. Okay, so 5 times 21.5 and then minus 3. You got to multiply first, and then you're going to subtract. When you do so, it's going to come out to 104.5. So one angle is 104.5. Some of you instead were setting each of these angles equal to 180 degrees. Does this look like it's a straight line? It's not. Got to be careful about that. Okay, my next angle, I've got 2x plus 7. Again, I'm going to replace the x with that 21.5. So I'm going to do 2 times 21.5 plus 7. Okay, now make sure that this looks like double arrows instead of an equals. Okay, so 2 times 21.5 and then plus 7, that's going to come out to 50. So now we have 50 degrees. Okay, then our last one, x plus 4. X plus 4 means that we're going to take 21.5 and we're going to add 4. 21.5 plus 4 comes out to 25.5. And if you wanted to check it, you could add 104.5 plus 50 plus 25.5, and you would get 180. Okay, any questions about that one? All right, let's go on down to the next one. The triangle inequality theorem. Triangle inequality theorem, remember, stated that in order for it to be a triangle, the sum of the two smallest sides has to be greater than the largest side. So when we're talking about picking out a range, so we've got two measurements. We need to pick out the third measurement, and we want a range of different possible answers. In this problem, does it say anything about whether these are the smallest or one of them's the largest? No. So the third possible side could be a small side, or it could be the large side. So what you have to do is you have to think about what's the smallest number it possibly could be to what's the largest number it could possibly be. So in order to figure out the smallest number, you have to think about it as one of the small sides. So if the third side was a small side, if the third side was a small side, we have to think about the fact that that number, x, plus the next smallest number, what's the other smallest number? 8, has to be greater than 15. So we've got to think about what number can we put here that will make it greater than 15. So if you solve this, you would just subtract 8 from both sides and get that that third side has to be greater than 7. Can it be equal to 7? No. It has to be greater than 7. Now, what if it was the largest side? If the third side was a large side, if the third side was a large side, then that means that 15 and 8 would be the smallest sides. Right? 15 and 8 would have to be greater than the third side. So that means x is going to have to be smaller. The third side has to be smaller than the 15 plus the 8. Because that sum has to be bigger than the x. Well, what's 15 plus 8? That's not rhetorical. What's 15 plus 8? 23. 23. There you go. Okay, so I know that x has to be greater than 7, but it also has to be less than 23. Can't be equal to those values. So any number between 7 and 23 will work. There's your range. Now when they write this as a whole, you don't have to know this yet. You'll actually start learning this next year in algebra. When they write this as a whole, they're going to write it as, okay, well, x has to be greater than 7, but 23 has to be greater than x. So this is what the range will look like. It's either going to look like this, or 7 is less than x, which is less than 23. Either one of those is acceptable answers. Okay? Any questions about that one? All right, so what you're going to do right now, I believe, let me see here. Oh, let me go ahead and hit stop first. Hold on. Where's my...